In this video, what we're doing is we're considering trying to find the shortest distance between vertex P and X. We've got the same network here. We're going to use two different approaches to do it. Now, the first way, sort of trial and error method, I'm going to try and work out all the different paths from P to X, which don't involve backtracking, and just select the shortest one. Now, to do this, when I'm working my way through it, I'm going to try and be kind of ordered. What I'm going to do is I'm going to try and always pick the left-hand route when faced with a decision. So first one's just simply P, Q, T, W, X. That will get me there. Then I could go P, R. Now I'm faced with a decision. I'll go to the left, T, W and X. Or I could go P, R to U, faced with a decision, W and X, or PRU straight to X, or PRU to V and X, or PR, and I could go straight to V to X, and I think that's just about done PR, and so the only other one is PS V to X. I'm going to pause the tape now and add up some of these distances, and I'll see if we can work out which one's the shortest distance. You might like to have a look at doing that too. Okay, we're back now, and I've done some adding up, and I've found that the shortest route is this one, PRUVX, just by adding all the distances up, and I looked in, that one seemed to be the shortest. We're talking about here in minutes, so the shortest, we're talking about distance in terms of time, the shortest time between, travel time between different towns. Okay, let's do the same question another way now, and what we can do is we can work out, what we're doing is we're working through this using a sort of algorithm. What we do is at each, we put a 0 in the first starting vertex because it takes no time to get there. We're talking times here. Then at each vertex we ask ourselves, what is the shortest possible way of getting there and how long would it take? So we could get to Q in 30 minutes. And we usually say that is via P. That's going to help us later when we backtrack to find the correct, the shortest distance. Now I can't fill this one in for T yet because I need to know this. How long does it take to get to R by the shortest route? Well, it will take, I can get there straight, directly. It will take 60 minutes to get there straight from P. Now I can go back to this vertex here, T, and I could say, what is the shortest way of getting there? Well, I could come in this way, and that would take me 60 minutes plus 20, that would take me 80 minutes to go that way, or I could come from Q. It took 30 minutes to get to Q, plus another 40, that would be 70 in all. That's shorter than coming in this way. So 70 is the shortest possible way I can do it, and that would be coming from Q. Okay, I can't fill this network in. I must have all the predecessing ones, so I need to know this one before I can fill this one. What's the shortest way I can get to this one? Well, I can only come from R, and it took 60 minutes to get to there, plus another 30 is 90 minutes to get there, and I would have come from R had I done it that way. Now I could probably have a look at this one and say, well, it took 70 minutes to get to there, so if I came in this way it would take another 50 minutes, all up 120 minutes, or I could come in this way, takes another 15 minutes, that would be 105 minutes. So the quickest way to get to W is via U, sorry. So that would be 90 plus 15, 105 minutes coming from U. Okay, what about V? We can't fill that in because we don't know this yet. Let's do this one. The quickest way to get to S, there's only one way, and it's directly from P. 90 minutes it took us to get there from P. Okay, now to get to V, there's three ways we could do it. Either we could come in this way, 10 more minutes here from U would do it, so that would be 100 minutes that way. If I came in this way, that would be 110 minutes, or I came in this way, 130. So the quickest way to get there is from U. We will take it 100 minutes in all. And now we've got to our final thing. There's three ways to get in there. We could come in this way, 155 minutes. We could come in this way, 160 minutes, or we could come in this way, 140 minutes. The quickest way to come in is this way, 140 minutes, and it's coming from V. Okay, so what we've found is the shortest way to get here takes 140 minutes. It's the same as the last one. And what route do we take? Well, you can backtrack. Starting from X, it says go back to V. From V, go to U. From U, go to R. And from R, go back to P. And so that is the shortest route through the network. Okay, doing it forwards direction, it's P, R, U, V, X. P, R, U, V, X, 140 mins, which is exactly what we found up here by listing all the different possibilities.